We always think about AI's limits in terms of software or algorithms, but what if the real problem, the biggest roadblock, is just electricity? Today, we're going to talk about a totally different way to compute, one that could solve this whole mess by swapping electrons for photons. Yeah, we're talking about computing with light.
So here's what we're going to cover. First, we'll look at AI's crazy power problem. Then we'll get into the solution, computing at light speed. We'll break down exactly how light can do math, see how it stacks up against the big dogs like NVIDIA, and then, the reality check. Why isn't this stuff everywhere yet? And finally, we'll ask the big question, is this the dawn of a new age in computing?
All right, let's dive right in. The first big thing we need to tackle is this energy bottleneck. Because as AI gets smarter and more powerful, it's also getting incredibly hungry. It's developing this ravenous appetite for electricity. And honestly, it's pushing our current tech to its absolute limit.
And seriously, think about it. Is AI's biggest problem really just electricity? It sounds kind of weird, right? We think of AI as this, abstract thing living in the cloud. But the reality? It's all running on very real, very physical hardware that just guzzles power. And that has become a massive roadblock for how fast it can grow. Okay, check this out. 700 watts. That's how much power a single top-of-the-line NVIDIA H100 GPU can suck from the wall at its peak. And that's the chip that's basically the engine of modern AI. Just one of them. So you take that 700 watts, and now imagine scaling it up. Not just a few, but thousands. Tens of thousands of these GPUs packed into a data center. All of a sudden, you're not talking watts, you're talking megawatts. Enough power to run a small city. And with all that power comes a ton of heat and just insane costs. We're literally hitting what people are calling a power wall, and it could genuinely stall AI's progress. So how do you get past a wall like that? Well, there's this one company, Lightmatter, and they have a pretty radical idea. They think the answer isn't to just build a slightly better electrical chip, but to, get this, stop using electricity for the really hard math problems entirely. And that brings us to the core idea here. Photonic computing. So instead of forcing electrons through tiny copper wires, you're guiding photons, actual particles of light, through these microscopic channels on a chip. It's a fundamental shift that goes right after the biggest problems of today's chips, heat and speed. I love this quote because it just makes it so easy to understand. It's like giving computers built-in flashlights for their brains. It's a perfect analogy, right? Instead of electrical pulses, the chips are literally using tiny, controlled beams of light to think. Okay, I know this probably sounds like something straight out of science fiction, but how does a computer actually do math with light? Well, it turns out it all comes down to a few really elegant physical principles. So let's break it down. Electrons versus photons. When you push electrons through a wire, they run into resistance, and that friction creates heat. It's just physics. But photons, they have zero resistance, which means no heat. They're incredibly efficient. And speed? Electrons actually move pretty slow, believe it or not. Photons, well, they move at the speed of light. But here's the real kicker. You can have multiple beams of light pass right through each other without messing each other up. That allows for this massive parallelism, doing a zillion calculations all at the same time, which is exactly what AI models crave. All right, so here's the super simple 3-step version of how this works. Step 1, you take a number and you encode it into the brightness of a tiny laser beam. Brighter light, bigger number. Simple. Step 2, you shoot that light through this incredible grid of what are basically tiny light bridges. The chip splits and recombines these beams over and over, and in doing so, it performs these massive calculations, the kind of heavy lifting math that AI is built on, almost instantly. And then, step 3, a little sensor at the end just measures how bright the light is when it comes out. That brightness, that's your answer. Now, it's really important to get this straight. This isn't about throwing away all our old electronics. Not at all. It's actually a hybrid system. Lightmatter's chips are super smart about this. They use light for the thing it's amazing at, that super heavy, repetitive math AI needs. But they still use regular electronics for things like control and storage and logic. So you really get the best of both worlds. Okay, so the tech is super clever. We get it. But the million-dollar question is, how does it actually stack up against the reigning, undisputed champion of AI hardware, NVIDIA? Well, if you look at the benchmarks, the performance jump is pretty wild. One test showed a Lightmatter system hitting 3 times the AI inference throughput. Now, inference throughput is just a fancy way of saying how many answers it can spit out per second.
So 3 times as many answers compared to a really powerful NVIDIA system with multiple GPUs. To put that in real terms, imagine a job that takes NVIDIA 3 days to finish. This tech could potentially get it done in just 1.
And when you have performance gains like that, you can see why the company's CEO is making some pretty bold claims. They're not just trying to be another option on the market. Their goal is to become the new standard, the very foundation for the future of high-performance computing.
Okay, I know what you're thinking. This all sounds a little too good to be true, right? Which brings us to the big, obvious question. If it's so amazing, what's the catch? Why isn't this stuff already in all of our computers?
Yeah, let's get real for a second. Because having a promising new technology in the lab and actually getting it out into the mainstream are 2 completely different ballgames. And photonics, well, it has some huge hurdles to overcome.
And these are not small challenges. First off, just making these things is really complex and expensive. The supply chain for it just doesn't exist yet, not like the one for silicon that we've been building for decades. Then there's this massive problem called optical memory. Think about it. How do you store data using light? It's like trying to write on water. As soon as you turn the light off, the information is just gone. And finally, you've got the integration problem. Every single time you have to convert a signal from light back to electricity to talk to the rest of the computer, you introduce a tiny bit of lag. And all those tiny delays can start to add up and eat away at that amazing speed advantage. But even with all those very real roadblocks, you can't deny that the momentum is building. The industry is starting to wake up and place some pretty serious bets on this tech. I mean, just look at what's happened recently. Light Matter raised a whopping $400 million in funding. That tells you investors are confident. They've also partnered with Global Foundries, a huge chip manufacturer, which is a massive step towards mass production. And they're joining these big industry groups, which means they're not trying to go it alone. They're working to make sure their tech can plug right into the data centers of tomorrow.
So all of this leaves us with one big final question, doesn't it? With our current chips slamming into a power wall and this new light-based technology picking up speed, could we be standing at the dawn of a completely new era in computing? Only time is going to tell for sure, but one thing is absolutely clear. The race to build the future of AI is on, and it just might be fought at the speed of light.